This video is going to go through an example of choosing the correct uniformly accelerated motion equation and using it to solve a problem. Jill stands at the edge of a platform that is 15 meters above the ground and throws a rock straight up with an initial speed of 13 meters per second. How long does it take to reach its maximum height? The very first thing we are going to do is define which direction is positive and which is negative, so we know when we look at velocity and acceleration which signs we should have in front. We will use the typical orientation where up is positive and down is negative. First, let's write down everything we know and what we are trying to find. This will help when we have to choose an equation. We know the initial velocity is 13 meters per second. This will be positive since initially the rock is thrown up, which we defined as positive. The acceleration is negative 9.80 meters per second squared. It is negative because down is defined to be negative, and the acceleration due to gravity is acting downward. The final velocity is 0 meters per second because this is the point where the rock reaches its maximum height. At this maximum height, the rock is no longer moving for a split second. We are trying to find time, so we will write that down as well. Now we can use this information to find our basic equation that will include initial velocity, acceleration, final velocity, and time. The equation that includes all four of these variables is final velocity equals initial velocity plus acceleration multiplied by time. Now we can take this basic equation and rearrange it, solving for time. This gives us the equation time is equal to final velocity minus initial velocity divided by acceleration. Make sure you use parentheses around final velocity minus initial velocity or hit the equals button on your calculator before you divide by the acceleration. Last, we can substitute 0 meters per second minus 13 meters per second divided by negative 9.8 meters per second squared. When we subtract and then divide, we should end up with time of 1.33 seconds. Next, we need to find the maximum height above the platform the rock reaches. Again, we want to write down all of the information that we know. The initial velocity is still 13 meters per second, acceleration is negative 9.8 meters per second squared, and final velocity is 0 meters per second. This time, we are trying to find the displacement, which is the maximum height the rock reaches. In this problem, we need to find a basic equation that includes both initial and final velocity, acceleration, and displacement. The basic equation that we want to use is 2 times a times s is equal to the final velocity squared minus initial velocity squared. Now we need to rearrange this into a working equation written in terms of s, or displacement. This gives us s is equal to final velocity squared minus initial velocity squared divided by 2 times the acceleration. Last, we can substitute in everything we know, and we are left with 0 meters per second squared minus 13 meters per second squared divided by 2 times negative 9.80 meters per second squared, and that is equal to 8.62 meters. Now that we know how high the rock travels, we can find at what speed the rock hits the platform. If we assume that Jill releases the rock while touching the platform, it will hit the platform with the same speed as it is thrown at. This means the speed it hits the platform at is 13 meters per second. This makes sense because the only force acting on the rock is the acceleration due to gravity, and since this force is constant, the initial velocity will be the same as the velocity the rock hits the platform at. Last, we want to find the total length of time the rock is in the air. If the rock is strictly moving in the vertical direction, then once the rock is released, the only force acting on it is the acceleration due to gravity. Since the initial speed and the final speed of the rock is the same, this means that the rock is in the air the same amount of time when it is moving up as when it is falling down. This means we can take the time the rock was in the air before reaching its maximum height and multiply that by 2 to account for the rock taking the same amount of time to fall back down. To find the time, we will multiply 2 by 1.33 seconds. This gives us a total time of 2.66 seconds that the rock was in the air. The other way we could have found this answer was by using the equation time is equal to final velocity minus initial velocity divided by acceleration. This concludes our uniformly accelerated motion example.